Hi, today we are going to be combining our next two lessons, 3.3 and 3.4, into one video and then practicing over the next couple of days. The goal today is to learn and refresh our memories on how to multiply with decimals. 3.3 just deals with whole numbers and decimals and multiplying those together, and 3.4 will be decimals and decimals as our two factors. Make sure you have your math notebook. We are going to fill out our table of contents, and we need to fill out page 10. And the foldable that you got in class is titled Multiplying Decimals Two Ways. So I want you to write that in your table of contents and then get your foldable and scissors ready. So the directions are on the foldable itself. Basically, you're going to fold this in half. It's a little bit shy of being perfectly in half, but it's close. And then you're going to cut on the dotted line. So you're going to just make it a little bit smaller. That way it'll fit in your notebook. And then you're going to cut the front so that there are two doors. And then the last step is to just fold so that it will flip open like so. Then you can glue it onto page 9 after you're done writing on it. That would be my suggestion. That way the glue won't interfere with you actually writing the notes on here. This is blank, and I'm going to be writing on the board. And while I'm writing on the board, I want you to be writing on this foldable, and I'll tell you how that works in a second. Just a quick vocabulary refresher. I know we talked about products in the lesson before. A product is an answer to a multiplication problem. Today we're going to be talking and using the word factors. And remember, factors are the two numbers that are being multiplied together. So you have your foldable. And what you will need to do is first we're going to talk about the more traditional way of multiplying. That involves counting the decimal places. So go ahead and flip open this right-hand side of your foldable, and underneath, on the bottom, we're going to be writing the steps, and then we're going to do an example on the back of the actual flat. So the first step, and there's going to be 5, so just make sure if you're writing a little bit large, you're going to run out of room. So make sure that you're writing a little bit smaller. So I'm going to write step 1. You're going to estimate first. Okay. Step 2, and switch colors here, right underneath. Step 2, we are going to set up our problem. So set up. The thing I want you to add here is I don't want you to worry about where the decimals fall. Don't line up decimals. When we were adding and subtracting, we did. When we're multiplying, we don't need to worry about it. Step 3, we are going to multiply the whole numbers, and we're going to ignore the decimal point. To have a little shortcut, decimal point, DP. Make it a little bit easier on your hand. Step 4 is the important one. We are going to count the decimal place value places. We're, for short, just going to call them the spots. How many spots or numbers are to the right of the decimal point? We're going to do that for both factors. Once we have counted those, we are going to add them all up. last step. Before, I know it's a little bit more writing heavy today. Step 5 will be to move the decimal point decimal point, DP, in the product. So now we are talking about the answer. So I'll just do answer here for you to remember. We're going to move the decimal point in the product so that there are the same number of spots to the right of the decimal point as what we just added. Move the decimal point in the product. We're not going to write all that. The same number of spots. Again, we're going to do an example so that we follow all of these steps. So that's going to be above on your foldable, right above. We are going to write example, actually up at the top, and we're going to write our original problem way up at the top. So it's going to be 0.45 times 0.012. If I were reading this the right way, not just saying 0.45, it would be 45 hundredths times 12, and this is the thousandths place, so 12 thousandths. First thing our step said in black was my color code. I'm going to do black again just to make it make sense. We're going to estimate. Now be careful when you are estimating small numbers. It gets a little bit tricky. This, when we're estimating, is the tenths place, it's the largest place value place, so we're going to call this decimal a half, 0.5. We're going to be multiplying it by, and this is a very small decimal, I'm going to call this number 0. I know there's something, but it's very, 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 very close to 0, and therefore, just to make it simpler, we are going to just say that that second factor is 0. Very easy to multiply now. Our answer is going to be somewhere close to 0. It's going to be a decimal that's very small. That's our purpose for the estimate. Step 1, now we have to set up our problem. Remember I said ignoring the decimal places. I prefer to use grid paper or line paper turned sideways. I don't have any here, sorry. But basically you want to write your first factor down, and that edge, that last number you write down, you want the second factor to be in line with it. So I'm going to start at the very end of that number and write it directly underneath the 5, and then go backwards and then put in our decimal point. Notice the decimal points are not lined up. That's okay. This is going to be the traditional way of multiplying. And now we are going to multiply ignoring the decimals. So 5 times 2 is 10, carrying the 1. 8 plus 1 is 9. Then I'm going to go below to do the 1 times 5 and the 1 times 4. When I add, I'm going to have to annex the 0. That is one thing that I did not mention on the steps below. So we're going to add that to the bottom when we're done with this example. Don't let me forget. Now we're going to add up these numbers just like we would with a normal multiplication problem. And we get 5, 4, and a 0. Now we have to do step 4 and 5. Step 4 was to count the decimal spots or places to the right of the decimal. So I have 1, 2 place value places, and I have 1, 2, 3 place value places in the second factor. What's 2 plus 3? 5. That means we have to make this answer have 5 spots to the right of the decimal point. So I'm going to start here and count 1, 2, 3, 4, 5. That is where my decimal is. Now remember, the annexing 0 comes into play here. We have 2 spots that we need to hold with zeros. Technically, it's good measure to also put one to the left of the decimal point, since this is a number less than 1 whole. So that means our answer, after we annex our 0, is 54 10,000ths. Notice I dropped this 0 at the end. That's okay to do. If you put it on there, that's also acceptable. So go back down, and on the very, very bottom, I want you to add that last little note that we might have to annex zeros if needed. So go ahead and write that at the very, very bottom, and now we're ready for our second way that we can multiply. Before we do the lattice way of multiplying, I just wanted to explain that a way to do an operation, multiply, divide, add, or subtract, is called an algorithm. Now we're just talking about 2 today, but there's lots of different ways to arrive at an answer when you are doing computations. We're going to practice mental ways to do that throughout the year, and these are just 2 to get us started as a foundation that I've used in the past that kids have had success with. So here's lattice, here are the steps. Similar to before, I'm going to write the steps below, and then we're going to do an example above. Step 1, just like for traditional, we are going to estimate first. Gives us an idea that we're on the right track. The second step, step 2, will be to set up, but it's going to be that we're setting up a lattice box. So set up, we're going to draw a lattice box. Step 3, we are going to, once our lattice box is made, put the factors around it. So we're going to place factors around the boxes. And we are going to include the decimal points when we set that up. Include decimal points. Step 4 is going to be actually multiplying the whole numbers. I'll show you how we write it in the boxes. Multiplying whole numbers together. And this step is kind of 2 in 1. After we multiply, just like in traditional, we are going to have to do some addition. We are going to be adding on the diagonal. And I'll show you what I mean when we do our example. Add on the diagonal is the last part of step 4. The final step for lattice, just like with traditional, is to deal with that decimal point. Step 5. We are going to bring the decimal point down from where it is on the outside of the lattice, and we're going to bring across. There's going to be 2 decimal points in every problem. The 2 factors will both have decimal points, even if it's a whole number. There is a decimal point to the right of that whole number. There'll always be 2 decimals to bring down and across. So bring down and across the decimals, decimal points, till they meet. Then we do what I call ride the slide. It rhymes. It hopefully will help you remember how to put that decimal point in the actual answer or product. So let's do an example. So on the top of your notes, I'd like you to write that example. And here is the problem we are going to try. We are going to try 0 and 39 hundredths, and we are going to multiply that by 2.4. First things first, we have to estimate. We're going to take this first factor and call it 0.4 or 4/10, and we are going to call the second factor just 2. Now, using what we just learned about traditional multiplication and counting decimal places, we have 4 times 2, which is 8, but one of our factors has a decimal place in it, so that means our answer has to also have one decimal place to the right of the decimal point. So that means our estimate is 0.8. Now on to the lattice. One of my tips when you're drawing lattice boxes is you need to make them big enough so that you can see the numbers that you're going to write on the inside. That's one of the problems that I've noticed over the years of doing this. Kids make the lattice box too small. Make it big enough. Just looking at the digits 3, 9, 2, and 4, I know I'm going to need 2 spaces on the top and 2 spaces, 1, 2 on the side. I can ignore the 0. Anything times 0 is 0. It's a waste of time to put that in there. And our lattice box will have the diagonals going from the right-hand corner down to the left-hand corner of each box. Make sure they extend a little bit on the side. Now we're going to place our factors around the lattice boxes. The numbers go in these spaces, and the decimal point gets lined up with the edge or one of the lines of the lattice box. So the 2 and the 4, and then the decimal point gets lined up right with the middle of this. Now we're ready to multiply. 9 times 2 is 18. One number in each of the triangles. 9 times 4, 36. 3 times 2 is just a 6, so we're going to hold that decimal place. And 3 times 4 is 12. Now we're going to add on the diagonal. These diagonal lines have created 4 diagonal spaces. So 6 times nothing is 6. We're going to add up 8, 3, and 2, which is 13. Similar to traditional, we're going to carry the 1 into the diagonal row above it. And 1, 7, 8, 9, and nothing for the top diagonal row. So, just a little hint too, when you carry, I put a little circle around this one so that I didn't forget it. Sometimes that's a mistake as well. Last step is the decimal placement. Here's the decimal in the first factor. We're going to drag it down, and the decimal here, we're going to drag it across until they meet here at this slide. This is what we drag the decimal point down to, telling us that it's in between 0 and 9. Our final answer then will be 0 and 936 thousandths, which is very close to 0.8. 2 examples I'd like you to try. You can use the next page in your notebook and just call it page 10 as well. The 2 problems, one deals with a whole number, and then another factor has a decimal, and then the second problem has both the factors having a decimal placed to the right of the decimal point. Remember, there is a decimal point here. It's sitting right next to the 4, even though there's no place numbers to the right of it except for zeros. I would like you to pick lattice for one and then do traditional for the other. In class over the next couple days, we'll get to know which one works best for you, and then you'll stick with that one. But for the purpose of this, I'd like you to pick one way per problem. You can check with a calculator, and we're going to practice it in class tomorrow. See you later.